Is this email spam or not? Is this tumor malignant or benign? Is this transaction fraudulent? Classification is the most common task in machine learning, and logistic regression is the algorithm that started it all. Welcome to Episode 7. Today we're learning logistic regression, the go-to algorithm for binary classification. Despite its name, it's actually a classification algorithm, not regression. Remember linear regression? It draws a line and predicts any number. But for classification, we need probabilities between 0 and 1. We can't have a model predict negative 0.3 or 1.7 for a yes or no question. The solution: take linear regression's output and squash it through the sigmoid function, which maps any number to a value between 0 and 1. The sigmoid function is the heart of logistic regression. It takes any real number and outputs a value between 0 and 1. When z is very negative, sigmoid outputs near 0. When z is very positive, it outputs near 1. At z equals 0, it outputs exactly 0.5. This S-shaped curve is what turns a linear model into a classifier. The loss function for logistic regression is called binary cross-entropy. It penalizes confident wrong predictions heavily. If the model says 99% spam, but it's not spam, the loss is huge. If the model says 99% spam and it is spam, the loss is tiny. This pushes the model to be both correct and confident. For classification, accuracy alone isn't enough. We use the confusion matrix. True positives are correct positive predictions. True negatives are correct negative predictions. False positives are false alarms. False negatives are misdetections. From these, we calculate precision, recall, and the F1 score. Precision and recall are a trade-off. High precision means few false alarms. When you say positive, you're usually right. High recall means you catch most positives, you don't miss many. In spam filtering, you want high precision so real emails aren't deleted. In cancer detection, you want high recall so no cancer goes undetected. The F1 score balances both. What about more than two classes? For multi-class classification, we extend logistic regression using softmax. Instead of one sigmoid output, softmax gives a probability distribution across all classes. The probabilities sum to 1. The class with the highest probability wins. This is how image classifiers decide between cat, dog, bird, and everything else. You now understand logistic regression and classification, from sigmoid functions to confusion matrices. Next up, decision trees and random forests, algorithms that learn by asking questions. Subscribe, and I'll see you there.